Good afternoon to all of you. Myself Dr. Kashmina Kapadia Memon. Today I am going to explain you about the photogrammetric survey. Photogrammetry. The method of determining the shape, size and position of objects using the photographs. It is based on the possibility of optically projecting the terrain into a flat surface. Photogrammetry is used to determine the spatial information like distance, elevation, area, volume and cross section. And it is used for construction of topographical map. There can be two types of photogrammetry. One is aerial photogrammetry and one is terrestrial photogrammetry. In aerial photogrammetry, the photographs are taken from air, and in terrestrial, photographs taken on or near the ground. There can be two types of photographs. One is vertical photograph, one is oblique photograph. Vertical photograph seen like this, oblique like this. Now, advantages of aerial photograph: speed of coverage of an area, then ease of obtaining topography in inaccessible area, freedom from possible omission of data in the field, and tremendous amount of details are shown. What information can I find on air photo? I can obtain the shape, I can obtain the pattern or size or tone or color, shadow, texture, and association or site. So aerial photogrammetry, here this is the ground surface, there is one optical axis, then exposure station, positive and negative, upper is negative and lower is positive. Now there are definitions of certain technical terms. Exposure or air station is the point in the air occupied by the front nodal point of the camera lens at instant of exposure. Perspective projection. A projection is said to be perspective when the straight rays radiate from common or selected point and pass through points on the sphere to the plane of projection. Then third is perspective center. The real or imaginary part of a origin of the bundles of perspective rays is known as perspective center. Then flying height is the elevation of exposure station above mean sea level. Then line of flight is a line which represents the track of an aircraft on an existing map. Focal length. This distance from the front nodal point of the lens to the plane of photograph. Then principal point P and capital P. A principal point is a point where a perpendicular drop from the front nodal point of the camera lens strikes the photographs. Then there is nadir point or plumb point. The point where a plumb line drop from the front nodal point strikes the photograph. Then there is a principal plane. It is a line of intersection of principal plane with the plane of photograph. Then tilt. Tilt is the angle with the plumb line. Then there can be tilted photograph at the time of exposure if the camera axis is tilted intentionally from plumb line by a small amount, usually less than 3 degrees. It is known as tilted photograph. Then isocenter is the point I in which the bisector of the angle of tilt meets the photograph. Then swing is the horizontal angle measured clockwise in the plane of photograph from positive y-axis to the plumb point is known as swing. Then azimuth of the principal plane is the clockwise horizontal angle measured about the ground nadir point from the ground survey north meridian to principal plane of the photograph. Then horizon point, the point of intersection of principal line produced with the horizontal line or through the exposure station is known as horizon point. Then scale of vertical photograph on flat area. S is equal to AB upon capital AB. Okay, so it is the scale f upon h dash. F is the focal length of aerial camera and h dash is the flying height above the ground. So mirror stereoscope is used. So it is used generally for producing the stereoscopic vision, means overlapping photographs in 3D view. The impression of depth is caused by relative apparent size of near and far objects and effect of light and shade. So, viewing an object simultaneously by two eyes, which are separated in space, is called stereoscopic vision. the algebraic difference between the two images of a ground point from their perspective principal point measured parallel to the airbase is called parallax. Parallax heighting is the process of finding the height of an object from stereo pairs of photographs that have no tilt and they are taken from same flying height. So sometimes we have to do the flight planning. So in order to obtain stereo pairs, every part of the ground is to be surveyed, must be photographed at the twice. At least 2 times one point has to be done. So there will be certain overlap will be obtained. So there can be forward overlap or there can be lateral overlap. Forward overlap means first, second, third, this type of photographs are taken in forward direction, and in the side lateral, in the lateral direction, this type of overlap is obtained. So overlap and side lap. Generally overlap is taken as 55 to 65% and side lap is between 20 to 40%. Then this is the air base. Then LP is the length of photograph in centimeter in the direction of light. LG is the net ground distance corresponding to LP. WP is the width of photograph in centimeters at right angle to the direction of light. WG is the net ground distance corresponding to WP. OL is the percentage longitudinal overlap. OW is the percentage of side overlap. S is the scale of photograph. AP is the net area of ground in each photograph. AG is the total area to be photographed. N is the number of photographs required. So by using this overlap formula, E percentage is equal to G minus B upon G into 100. And here G minus W upon G into 100. Total number of photographs we have to take is LG is equal to S LP 1 minus OL. WG is equal to S WP 1 minus OW. Where theoretical spacing of light strip is WG and theoretical number of strips will to width of the area upon WG. So actual number of strips is equal to K plus 1. So theoretical number of photograph per strip is equal to length of area upon LG. So actual number of photograph per strip is equal to M plus 1. So actual number of photograph for complete coverage of area N is equal to K plus 1 into M plus 1. Now let us solve one numerical example based on this. In pair of overlapping vertical photographs, the mean distance between two principal points lying on the datum is 6.385 centimeter. The flying height of the photography was 580 meter above datum. Determine the difference of parallel for top and bottom of tower of height 115 meter having base in the datum surface. The focal length of camera is 150 mm. Capital B is equal to B upon F into H. So it is 6.385 divided by 580 and H is 15. So it is divided by 15. So it is coming out to be 246.89. Parallax is given by P is equal to BF divided by capital H minus small h. So here bottom of the tower H, small h is equal to 0. So PT is equal to 249.85 into 150 multiplied by 580 minus 115. So it is 79.64. Similarly, PB is equal to 246.89 into 150 upon 580. It is 63.85 mm. The difference of parallax is given by this is PT, this is PB. So it is 15.79. So the result can be checked by delta H is equal to 115 meter in the given value. Thanks.